Hello, today we are starting chapter 4. I'm going to divide this into 3 sections. Today we are doing 4-1, part 1, trig ratios. Let's get rid of that typo. Trig ratios with special right triangles. Today's date is today, and we have 3 objectives. We're going to find the 6 trig ratios. The second one is if given one ratio, we'll find the other 5. And our last objective is to find the trig ratios on special right triangles. So, right about now, I'm sure you're asking yourself, gosh, I wonder what those trig ratios are. Well, the ones on the left are the ones that we are going to use the majority of the time. The sine, the cosine, and the tangent. And you probably heard of that mnemonic device, SOHCAHTOA. Sine, opposite over hypotenuse, that's where the SOH comes from. Cosine is adjacent over hypotenuse, that's where the CH comes from. And TOA, tangent, opposite over adjacent. So TOA. So if I look at my triangle right here, this only works for a right triangle. If you drew an arrow from your angle to the side across from it, that's always going to be your opposite. Just like the hypotenuse is always going to be across from the right angle. Your adjacent side helps make up the angle. So I would make a note, if I were you, and say memorize those. Those need to be memorized. The ones over here, the cosecant, secant, and cotangent, you'll want to memorize those too as well. But if you notice, sine and cosecant are just kind of inverses of each other. This is hypotenuse over opposite. Cosine and secant are inverses of each other. That's hypotenuse over adjacent. Tangent, cotangent are opposite, adjacent over opposite. I know one thing that has helped me remember which ones are paired up. You'll never have a co with another co. So right here, sine and cosecant go together. Only one of them has a prefix of co. Cosine and secant go together. Only one of them has a prefix of co. Tangent, cotangent, these are the only ones that make sense. Only one of them has a prefix of co. So make sure you have these down in your notes. Might need to hit pause for a second. These need to be memorized. Let's go with our first example. So we want to find the exact values of the other 6 trig ratios. So we've got our angle here. And if I were to draw a line across, I get 33. So I know 33 is opposite. 65 is across from the right angle. So I know that that is a hypotenuse, and 56 helps make up that angle. So I know that is adjacent. So opposite, hypotenuse, adjacent. Once you've got those identified, it's really just a matter of labeling everything. So I did a little cheat sheet right there. I put our triangle back over there. Our sine is going to be opposite over hypotenuse, which is 33 over 65. Our cosine ratio, and that's what we're looking for, our ratios, is going to be 56 over 65. Adjacent over hypotenuse. Tangent, opposite over adjacent, 33 over 56. And if I look over here on the right, my cosecant is just the reciprocal of sine. And you can always think of that too as 1 over sine theta, which is going to give me 65 over 33. Secant is really just 1 over cosine, which is a reciprocal. And so my answer is a reciprocal, which is going to be 65 over 56. And cotangent is 1 over tangent theta, which is going to be 56 over 33. All right. Why don't you hit pause and try these 3 on your own for these 3. There's just 1 here, I'm sorry. Try this 1 problem on your own. You've got a right triangle there. Identify the opposite, hypotenuse, and adjacent. And if you hear a dog in the background, that's Cosmo drinking water. The correct answer on that is going to be B. The sine is actually 12 over 20. It reduces down. Hopefully everybody reduced your fractions. Cosine, which would have been 16 over 20, reduces down. And tangent would have been 12 over 16, which again reduces down. All right, our other objective is to use one trig function or value to find the others. So on this one, they're telling us that sine of theta is 1/3. We want to find the exact values of the other 5 remaining trig functions for the acute angle theta. So we're going to start off just by beginning to draw a right acute angle and label one of them theta. Then we're going to take what we know. We know sine theta is opposite over hypotenuse, and that equals 1/3. So I'm going to label the opposite side 1 and the hypotenuse 3. Let's take a look what that would look like. Whoops, I'm sorry. Let's scroll down and find out what that would look like. That's what it would look like right there. My opposite is 1. My hypotenuse is 3. And then we're going to use our handy-dandy Pythagorean theorem to find the length of the adjacent side. A squared plus b squared equals c squared, and we get 2 radical 2. We want to leave it exact, no decimals. So now that we have that, it's just a matter of using your knowledge and coming up with those ratios. So if I'm going to go back up to the picture here real quick, cosine is adjacent over hypotenuse, which would be 2 radical 2 over 3. Tangent is opposite over adjacent, which is tangent 1 over 2 radical 2. And then I just found the reciprocal functions by taking the reciprocals of those answers. All right, here's one for you to pause on. Try it yourself. We want to find the remaining 5 trig functions for the acute angle, and we know tangent is 2 over 3. Start by drawing a triangle. You should get your hypotenuse, be able to figure out what your hypotenuse is. The answer here is D. If you notice, they did rationalize the denominators. It's always a good idea. You don't want to leave that radical down in the denominator. I probably should have mentioned to go ahead and rationalize them, but it is multiple choice. You should have been able to figure out that's exactly what they were doing. Because for the sine, I believe you get 2 over radical 13. To rationalize, you'd multiply that by radical 13 over radical 13. That's where the 2 radical 13 over 13 comes from. All right. Let's take a second and look at special right triangles. I'm going to come back and talk about this chart in just a second. I believe you talked about this when you took geometry, 30, 60, 90, 45, 45, 90 triangle. Those are special triangles. The side opposite the 30, I always refer to as the short side. The side opposite the 60, I always refer to that as my long side. And across from the 90 degree, that is always going to be your hypotenuse no matter what. So if you notice, they called the short side x. The hypotenuse is 2x. So you're multiplying your short side times 2 to get your hypotenuse. Your long side is radical 3 times x. So you take your short side times radical 3 to get your long side. Here, on a 45, 45, 90 degree triangle, your two sides or your two legs are exactly the same. And we're just going to call them legs. And to find your hypotenuse, that's going to be your leg times radical 2. Kind of sum that up right now here. To find the hypotenuse, multiply the leg by radical 2. So if this was 5, my other leg would have to be 5. My hypotenuse would be 5 radical 2. On a 30, 60, 90, there's my 30 degrees. Let's call the short side 5 and work from there. To find the long side, multiply the short side by radical 3. So my long side is going to be 5 radical 3. Remember, that's going to be the side opposite of my 60 degree angle. I don't have it labeled, but we all know that a triangle has 180 degrees. 90, 30, that would have to be 60. To find the hypotenuse, you multiply the, oops, I forgot the word short in there. Multiply the short side by 2, so 5 times 2 is 10. So if I were to come back up here, this is kind of just telling me what the values of some different angles are. The sine of 30 is 1/2. The sine of 45 is radical 2 over 2. The sine of 60 degrees is radical 3 over 2. And we're going to be using these a little bit more. This is kind of just the introduction to when we start using the unit circle, which is going to be coming up in a couple lessons. This is just kind of, I said, a way to introduce it. So if I were to, let's erase that just so that there is some, not so much writing. So if I said my short side is 1/2, and then I doubled that, that would make this side 1. And if I multiplied that by radical 3, I'd get radical 3 over 2. And that's how I'm coming up with those ratios. Sine is opposite over hypotenuse. So 1/2 over 1 gives me 1/2. To find the 60 degree, radical 3 over 2 over 1 would be radical 3 over 2. So down here, if I were to let my hypotenuse be 1, my leg would be 1 over radical 2, which when I rationalize that is radical 2 over 2. Let's make that 2 a little bit better. In the directions, I told you to multiply the leg by radical 2 to get the hypotenuse. But if we know the hypotenuse, you just do the opposite. You divide the hypotenuse by radical 2 to get the leg. So like if I wanted to find the sine of 45, it would be radical 2 over 2 over 1. You will have to know those a little bit later on. As I said, this is just kind of an intro of this, but it's something that will be useful. All right, I hope you enjoyed trig ratios. Get ready for an exciting part 2.